In this video, we're going to talk about what a logarithm is. By this video, you should be familiar with the exponential equation, such as y equals b to the x. Well, if I wanted to find the inverse of this, remember inverse, I would have to switch the x and the y. Well, much like square and square root, so as a side note, we have a function like y equals x squared. We don't say its inverse is x equals y squared. We typically say that y is equal to the square root of x. That would be plus or minus. So we use a different notation for its inverse. We're going to do the same thing with the inverse of an exponential. So instead of using this notation, x equals b to the y, we're going to use what's called a logarithm. So that means we're going to write it as y equals log base b of x. So this is what the inverse of an exponential looks like. As I said, this is the base, just as this was the base here. Now how we read this log equation here is this part would be read as y is, so y is, this log piece we'll write as the exponent so we'll say the exponent, and then we'll say on b, exponent on b that gives x. And that comes from here. So I will go across here. So we have y is the exponent on b that gives you x. And if you look above, y is the exponent on b that gives you x. So let's try some examples. So for instance, for my first example, I have log base 2 of 8, and I want to know what is that. And remember, to read this, it's the exponent on 2 that gives you 8. The exponent on 2 that gives you 8. So I don't know what exponent do I put on 2 that gives you 8. Well, we know that 2 cubed is 8. So that means this is equal to 3. Again, to read that, the exponent on 2 that gives you 8 is 3. So the exponent on 2 that gives you 8 is 3. Let's try another example. So let's say I have log base 4 of 16. I want to know what does this equal. Well, I read it again. The exponent on 4 that gives you 16 is what? Well, we know that 4 squared is 16. So that means that the log base 4 of 16 is 2. The exponent, so one more time, the exponent on 4 that gives you 16 is 2. The exponent on 4 that gives you 16 is 2. So log base 4 of 16 equals 2. Final example here. Let's suppose we have something a little bit more in depth. Maybe we have log base 5 of 625. We want to know what that is equal to. So if I read it, I want to know the exponent on 5. So where's the exponent on 5? It gives you 625, so it gives you 625. Is what? So what is that exponent? And just on the side here, I know that 5 to the 4th is 625. So that means the exponent would have to be 4. So log base 5 of 625 would have to have an exponent of 4. The exponent on 5 that gives you 624 is 4. If you tried to put in log base 2 of 0, what would happen? I encourage you to try that in your calculator. If you do it in your calculator, you should get an error. Well, why would we get an error? Well, let's see. This means the exponent on 2 that gives you 0 is what? What is that exponent? Well, if I put in some positive values, I get, if I put in 1, I get 2, 2, I get 4, and it's just going to multiply by 2 each time. If I put things less than 2, so like negative or less than 1, or like negative values, I get 2 to the negative 2, if you remembered. Negative exponents just mean go on the denominator. It's 1/4. If I do negative 3, I would get 1/8. If I do negative 4, I get 1/16. So that's not giving me 0. Positive values didn't give me 0. Negative values didn't give me 0. What if I actually do 0? Well, remember, anything to the 0 is actually equal to 1. So there's no function, there's no value put into this equation for an exponent that would make 2 equal 0. It's impossible. If you want to see more on that, you can look at the log graphs video. Final thing, if it doesn't have a base written, so there's no base written, like this automatically means that there's a base 10. That is our number system. Okay? This would evaluate to 10 to the what exponent? Would give you 100. Oh, that would be 2. So remember, if there is no exponent there, or no base there, we're going to assume that it's base 10.